more about what is a logarithm, and then can we use a calculator, can we evaluate some of these lovely things, and can we work with them? And so again, if you have a calculator, that would be a little bit beneficial for this particular lesson. Okay? Just a note from our last lesson, we might have a number called E. And if you look at your calculator, you might see a button that says like that, that says E. And so what the heck is that? Well, it's like a number. A number for E is just going to be like pi. It's just a number. And so E is going to be, again, this irrational number because it doesn't have an ending, and it just keeps repeating, it keeps going and going and going without repeating. So E is really 2.71, 8281, 828, and so forth. So it is just a basic number. We call that a natural base. And again, it's just basically showing, again, what the E function looks like. So do you see how this looks just like an exponential function? We'll talk more about E as we talk about solving. So, because like when we want to get rid of things, like what we call a natural log, then we talk about using E to do that. All right? But E is just like a regular number, so you can do math operations with E. Okay? So for example, here if we have e to the negative 9 power, and then we have e to the 12th, what do you think I'm going to do with the exponents? We're just going to add them. So we're going to have e to the third, because 12 plus negative 9 is going to be 3. So this is not in your section 10.2 just yet, but it's right by it. We just want to leave it as e to the third. If we wanted the decimal, yes, we can find the e key and then put in a power of 3, and then we're good to go. Number 2, again, just like polynomials like we were doing before, it's just e now is a number. So first of all, what can we do with the 25 and 35? Reduce. So 5 goes into both of those. So that will be 5. 35 divided by 5 is 7. And then what else can we do? We can cancel out 2 e's. So we're going to have 5 e's left on the bottom, and that's my answer. So 5, 7, e to the 5th. We'll talk more about e when we get there. I just wanted to introduce this particular number. The next one is actually kind of interesting because you've got a 2e. So if you think about that, what are we going to do with these two things, the negative 3x and the 5? We're going to multiply them. Very good, because the exponent's outside, so we're going to multiply it. So we're going to get negative 15x. Okay. Now, it's all about, like, do you see how the bases are the same? It's 2e. So since we're multiplying, we can first do what's 2 times 2, 4. And then e is going to stay e, and we can add these together. So negative 15x plus x is negative 14x, and then plus 1, because the plus 1 doesn't have any like terms, so then we just say that. So we can add things together, which is kind of like a funky version of number 1, really. And then, of course, we can do some square roots of things, too. So remember 16, if we're doing the 4th root, okay, so this is a quartic root, so 16 is really what to the 4th? 2 to the 4th. And so then what we can do is that to the 4th power just comes out, so that'll be 2. And then remember, to get this number with the e, we would divide by 4, so 24x divided by 4 would be 6x. So you can do fun mathematical operations with e. Well, I just wanted to introduce the concept of e. We'll come back to it, but I just wanted, there is no nice place to introduce it. But no, that's not your complete and utter notes. No, this is just an extra topic that we're kind of covering. Okay, now for the logarithm part, here I've got pictures of logarithms here. Okay, and you're kind of taking a look at the graph. And so when you're dealing with a logarithm, that's kind of showing you, again, it's not exactly exponential, but it just kind of shows what it particularly is going to look like. It's basically a reflection. So if you can see how, like, this is your growth curve. So this is a basic growth. And then this is your line of reflection. Here's your logarithm. So that's why sometimes we study logarithms, because we want to find the inverse of that particular exponential function. Same thing here. Here, again, we have the original one, again, is dealing with a decay, and then again, we're dealing with a form of reflection with that. So what is a logarithmic function? Well, a log basically is where, again, it's going to be dealing with a reflection issue. And here we're going to have, this is always going to be a positive number. That's your base. And then also you're going to have to be careful with that. The base is going to be a positive number, but we never really do it to 1. Because really 1 to any power is just what? 1, so we don't care. So what we're going to practice is this first big thing here. Y equals log b of x to the b, and then the second version is by equals x. So that means if I give you something exponential, can you change it in logarithm form? And vice versa. If it's in logarithm form, can you change it back into exponential? Okay? So for example, see how this is in exponential form. 2 cubed is 8. Let's change that and put it into log form. Okay? So to do that, the y is going to be, so if you think about this, this is by to the x. So now if I look at my log equation, what number is in the y position here? 3. So I'm going to write 3 equals, then I put log, then I need my base. So then I go to here, oh, b. So what number's in the b position? 2. So that's going to be my little 2. And then for the x, that is going to be the answer to this equation. So the number in the x spot is 8. Now, if you ever check my answer keys, though, I hate having a number by itself on the left-hand side. So you might see me write it like this. But you know how that's the same, correct? I just flip-flopped it over the equal sign, so they're identical. So a lot of times if you check your answers, I'm going to write it like this. Because I like having the log on the left side. It's just me. So that's what I like to do with that one. Okay, next one we're doing the same thing. We have 3 to the 4th power equals 81. So then the b, again, is going to be here. We have the y and then the x. So therefore, we're going to write this as, if you want, you can write the y value first. So the y value, what number's in the y position? 4. So we're going to have 4 equals, and then log. Then I need what number's in the base position, the b, which is 3, and then the x number. So the number in place of x is 81, or I could write it as log to the base 3, 81 equals 4. Okay, could we go backwards? If something is written in log form, could I switch it and change it into exponential form? So yeah, so this is really, again, log b, and then we have x equals y. Well, I'm changing it into b to the y equals x. So what number is in the b position? So that's your little number. That's 2. To find my exponent, that's y. I got to go look way over yonder. So that's 6. And then we set it equal to, again, x, and the number in our x position is 64. So we just kind of want to get used to logarithms and how they're kind of written. And so that would be what we call writing it in exponential form. Okay, for number 4, same kind of thing. So I would start out with the base. Where's the base? So where's the base? That's the easy thing to find. Where's the base? So 9. Okay, then I got to find my exponent. So 3 halves. And then equals 27. Wait. We're not solving anything, we're manipulating. I'm changing it from logarithm into exponential form. That's it. So I'm just writing it in a different format. I'm not solving anything. Not yet. Yeah, not yet. Okay, and then the next part, it's going to be to evaluate. So we're going to basically, how do we use our calculator with this? So we'll talk about that. And then we'll also talk about how you can do a basic equation solving, and then that's where we're going to stop. And then on Monday, we're going to talk about how do we solve equations like this. and then we're going to be talking about how the base matters. So I might be singing some Meghan Trainor for you on Monday. So things to look forward to. You know why I said that, right? Yeah, because it's all about that base. Or you can do the music version, be no treble. Treble, treble clef. Yeah, okay. So anyways, so to evaluate this function, what you would do is you can actually kind of do it in your head. Sometimes you can do it that way, or you can put it in the calculator, and so it just depends on what version you want to do. Sometimes I like to do them in my head because when I'm thinking about that, I'm kind of thinking about, okay, 4 to what power would make 64? You might be able to figure that out. And so that should be 3. No, it wouldn't be 4. 4 to the 4th, 4 to the 4th would be 256. Trust me. So if you want to put in log, first of all, you would stay away from the ln key. You actually need a log key. And then if you're using a regular calculator, it's going to assume that you're in base 10. So that can be a little bit tricky with that particular one. So this one I'm going to have to play around a little bit. The graphing calculators are actually a little bit nicer with log because they will allow you to change the base. So actually the graphing calculators are much better. So on these I would just hit the log button and then it should be able to where I can put in the bottom little number of 4 and then to the 64. I'll show you that in a little bit. This one we could say, okay, 10 to what power makes 100,000? So that's what we would be thinking. So we're okay with 4? Okay. And again, we could put that in the calculator, but these are so easy that it doesn't really pay to put them in the calculator. Oh, it's 5. Oh, thank you. Okay. And then the next one, 5 to what power makes 625? 4. You sure? Okay. Yeah, that's right. Okay. And then that's all you're kind of doing. So when you're evaluating it, you really don't necessarily need to use a calculator. You can just kind of figure it out. It's not horrible. And then for 8, 9, and 10, all you're going to do is just figure it out. So here, I'm going to put it back into exponential form. So a lot of times when we work with logs, it's easy to be able to convert it back and forth. So here's my base, 6. My exponent is way the heck over here. And that's going to equal x. So then we just have to think, oh, well, what's 6 squared? 36. Done. Then if I look at the next one, I'm going to have 3. That's my base. My exponent way over here, 3. That's going to equal x. So I have to think, well, what the heck is 3 cubed? 27. And then finally, the last one, we're doing 2. The exponent is -4. And then we have to figure out, well, what that is. So remember, if it's negative, don't worry about the negative right away. Think about what is 2 to the 4th. So what is 2 to the 4th? 16. Now remember, flip it. So this is 1/16. Okay, so that's your basic start of logarithms. And we haven't really spent too much time about what, what's the purpose of it, why do we use it for solving and things like that. That's coming down the road for next week on, Mondays and Tuesday and things like that. Okay, so questions on this?